Hello, amazing people. Welcome and let's solve this Math Olympiad exponential equation together. Remember, it's very simple. I'm going to make it much more simple for you. Join me and learn new skills today. So this is what we have. So we're going to just begin it with solution. Now, remember, because it's exponential, let me remind you of some of the rules that will guide us. One of them is that when you have a to the power of m to the power of n, it simply means a to the power of, this will multiply to give us mn. Did you see that? Now, let's see how this helps us. Now, for this, what we have there is 7 to the power of x plus this can be written as 7 to the power of x raised to the power of 2. Did you see? This is in this, and it is also the same as this. Okay? Then plus this will give us 7 to the power of x raised to the power of 3 is equal to 14. Amazing. Now, what do you do again? You'll notice that 7 to the power of x is common in each of the terms. So just quickly say, let 7 to the power of x be. Choose any letter of your choice. You can choose y. Okay? Now, we are going to replace this anywhere we see 7 to the power of x. So that is going to give us, to write this, I'm going to write y plus, to write this, I'm going to write y raised to the power of 2. This will give us y raised to the power of 3 is equal to 14. Now, when you look at this, you notice we now have one variable y raised, and the highest power is 3. And when you have an equation that has the highest power of that variable to be 3, it is said to be a cubic, okay? It's a cubic equation. So we're going to make this look more beautiful. So to do that, we are going to have the one with the highest power begins it, followed by the next one, then plus this y. And you see that 14 is positive at the right side. So to remove it, we are going to subtract. It's going to give us negative 14. When you subtract it, it becomes what? 0. So you see the equation we have gotten. Now, at this point, you can choose any convenient method to solve this. Join me as I show you how to use the trial error cum the factor method to solve this. Now, what we do here is we are going to now list out the numbers that can divide this 14. Okay, we have negative and positive 1, negative and positive 2, negative and positive 7, and the rest of them. Now, we are going to try which of this value can we substitute at the left side of this expression to make it to be equal to 0. Okay, now let's choose from when y is 1. Put it here, we're going to have 1 cubed plus 1 squared plus 1 minus 14. You notice that if you add this up, it's not equal to 0. So it means that y being 1 is not a solution. Okay, you can quickly do for when y is negative 1. Put it here, we have negative 1 cubed plus negative 1 squared plus negative 1 minus 14. Simplify this, you still see is not equal to 0. Now, what it means is that y being 1 is not a solution to this. So let's try for when y is 2. So in that case, we can say let y be equal to 2. So we put it here, we are going to have 2 cubed plus 2 squared plus 2 minus 14. This will give us 8 plus this will give us 4. This will give us 2 minus 14. And when you simplify this, it is equal to 0. And what it means is that y being 2 is a solution to this cubic equation. But remember, for it to be cubic, it means you are to get 3 values of y. But we've only succeeded in getting y as equal to 2 as one of the solutions. So let's get the remaining solution to this particular equation. Now, what we are going to do here is, remember that because this is a solution or the root of this equation, we need to get its factor. And how do we get it? It's just very simple. What you need to do here is that since here is positive, so you subtract, okay? We can now say that y minus 2 is a what? Is a factor. So if it is a factor, remember we have gotten this. For it to be cubic, like we said, it has to be 3. one linear and the other should be quadratic. So it means that this equation is similar to y minus 2 and ay squared plus by plus c, okay, equal to 0. This is the quadratic and this is this linear, okay? So if we expand this, it should give us equivalent to what we have here. Did you get it? So it should be equal. So let's do the expansion. We're going to use this to expand, okay? So we expand. So this is going to give us, y multiplies this will give us ay cube. Use it to multiply this, it will give us by squared. Use this to multiply this, it gives us cy. Then go with this, okay? This multiplies will give us negative 2ay squared. Now use it also here. We have negative 2by. Use it in the last, we have negative 2c, and everything is equal to 0. So what we need to do now is to collect the same powers together. So this is ay cube. Then for square, look at it. This is square and this is square. So let's collect it together. It's going to give us b squared minus 2ay squared. Now this one is cy, and this one is having y and this is having y. So we're going to have plus cy minus 2by, then minus 2c is equal to 0. So what do we mean? We have to factor again. We have ay cube plus, now y square is common, factor it out. So we're going to have b minus 2a y squared. Did you see it? Then here, see, y is common, so factor it, it will be c minus 2b, then y minus 2c is equal to 0. Now, what does this mean? It means that this equation is equal to what we have here. So we're going to compare it now to get the what? We are going to compare it. So in comparing it, we are going to have it that, remember, this is y cube and this is ay cube. So what does it mean? It means that the coefficient of this here should be equal to the coefficient of this. Did you see it? So in that case, by comparing, so we can just call this one as equation 1. Okay, let's call this 1, and this we can call it 2. Okay, so we can say comparing 1 and 2. What do we have? This means that our a is equal to 1. Okay, now what other thing do we have there? We have it that a is equal to 1. Then for y squared, compare it with this. Did you see y squared? So it means that this coefficient is b minus 2a is the coefficient of y squared, and the coefficient of y squared here is 1. So it means that b minus 2a is equal to the coefficient here, which is 1. I hope you are getting it. Then for this y, compare it with this. Coefficient here is 1 and this is c minus 2b. So if you compare it, you are going to have, this gives us c minus 2b is equal to 1. Okay, then minus 2c, which is the constant, is equal to 14. So we are done comparing. So let's get the value of a, b, and c. So in that case, we can just conclude to have it that our a is 1. Then for here, we are going to have it, if a is 1, put a value here, is going to give us b minus 2 multiplies a, which is 2 multiplies 1, is equal to 1. So if you simplify, you are going to have b minus 2 is equal to 1. So b will be, add 2 to both sides to be 1 plus 2, so that b will give us 3. Now, if b is 3, what do you do again? We need to get c, so that we replace it here and get the quadratic equation. So having gotten b as 3, then let's put in this b in this equation. So if you do that, we are going to have from here, this is going to give us c minus 2. Our b is 3, then is equal to 1. So we have c minus multiply this 6 is equal to 1, so that we have it as c, add 6 to both sides, we have c is equal to 6 plus 1, and when you add this together it gives you 7. So our c is 7, our b is 3, and our a is 1. So we are going to replace it in this quadratic equation to get the actual quadratic, and in doing that we are going to have it as, this is going to give us, replacing, we now have a, our a is 1, so it's going to be 1y squared plus, this is b, our b is what, 3, so it's going to be 3y, and our c is what, our c here is 7, so we have a 7. So it means that we are going to have, the equation becomes y minus 2, and this will give us y squared plus 3y plus 7 is equal to 0. So this is the equation we have now. Okay, so having gotten this, we are going to solve this equation. You see it's quadratic. We are going to solve it quadratically. So to do that, we are going to test for the discriminant to know if actually it's going to give us a real or complex solution. So let's test for the discriminant, and to do that, we use, for discriminant, we use our d is b squared minus 4ac. Okay, so in that case, we are going to have it that, and when you test it, it should be greater than 0. So let's put in, remember here is your a. So in that case, we are going to have testing, we are going to have it as b is 3, the coefficient here is a, which is 1. Okay, then this is our b, which is 3, and our c is 7. So put in here, we are going to have 3 squared minus 4 multiply 1 multiply 7. 3 squared is 3 times 3, giving us 9. If you multiply this, it gives you 28. And you see, when you subtract this, it is what? Less than 0. And because it's less than 0, we don't need such value. It means it's going to give us a complex solution. And what we want is the real solution. So in this case, we are not accepting this. So we conclude that our y is equal to 2. That's the solution we have. Now, having gotten this y, remember, we are not asked to find y. We want to find the value of x. Okay, but remember we said, so we recall, we said that 7 to the power of x is equal to y. So what do? Replace this y here, so that we have 7 to the power of x is equal to 2. Now, what do you do here? You know we cannot raise 2 to be in the same base with 7. So at this point, you need to introduce the logarithm. So taking the log of both sides, this is giving us log of 7 to the power of x is equal to log of 2. Remember your rule of log, which says if you have log of a to the power of n, you use n to multiply, and that gives you n log a. Okay, so apply it here. This will multiply. In that case, we have x log 7 is equal to log 2. Now, to get x, we divide by log 7, divide this by log 7. And if you do that, we are going to have x is equal to log of 2 over log of 7. But remember also that in your logarithm, if you have log a over log b, it is the same as log of a base b. Okay, we call it change of base rule. So we can apply it here, so that we are going to have it as our x will be equal to log of 2 then base 7. So this becomes the value of x for this question. But we are going to check to know if our answer is correct. To check, we are going to have, this is 7 to the power of, this is our x, so it becomes log of 2 base 7 plus 7 to the power of, this is 2 multiplying log of 2 base 7 plus 7 to the power of 3 multiplying log of 2 base 7. So what do? Let's remember this rule, okay? So in that case, we have 7 to the power of log 2 base 7 plus, you see this is multiplying just like this, so it will be returned to be this. So this is going to be a power now. So we have 7. So this is giving us 7 log 2 to the power of 2 base 7. Then plus, this will be returned to give us 7 to the power of log 2 raised to power of 3 base 7. Then remember there is this rule which says if you have a to the power of log b base a, where the base of the log and this base are the same, your answer should be equal to b, the anti-logarithm rule. So if you apply it here, you see we're going to now have, this will now be, this and this are the same, so the value should be 2, okay? Plus, this and this are the same, the value should be this, so it should be 2 raised to power 2. Then this and this are the same, so we're going to have it 2 raised to power 3. And when you have 2, this gives us 2 plus 2 raised to power 2 is 2 times 2 to be 4, and this will give you 8. And when you add this together, you see it gives you 14. And that is what we have at the right side of the equation. So it means that this value of x is correct. And I hope this helps you a lot. Let's know how much in the comments. Remember, helping us to share this helps the algorithm to catch it and send it to more people that need this skill. Remember to give us a thumbs up and subscribe for the more you will get. See you in our next class. Bye-bye.